Hello everybody, this is Coach Steinmeier for AP Pre-Calculus. We have some extra work for you here. We're going to work on limits algebraically. So if you look up here for limit laws, there's lots of different things with limits. Again, we have touched on limits before, but if you have a limit as, if you look at law number 1 here, if you have the limit of two different functions, and you're adding them, you can take the separate limits and add them, and you can kind of read through right there everything that you can do. You can multiply a constant by a limit, and it's the same thing. You can multiply limits. You can divide limits as long as the bottom limit is on 0. And we have to take the absolute value, or not the value, the nth power, and then the nth root. So just coming down here, I'm going to show you using the limiting laws. So if we have, for the first example here, if the limit as x approaches 3 of f of x is 2, and we have x approaches 3 of g of x is 0, find the following. So because these are both approaching the same limits, we can go ahead and use our limit laws here. So for this first question, I can rewrite this since these are adding the limit as x approaches 3 of f of x plus the limit as x approaches 3 of g of x. So the f of x value is 2 plus 0, so I get 2. Okay. Next one right here. This is the same thing, can be written as the limit x approaches 3 of f of x over g of x. Okay. So we can rewrite this as the limit as x approaches 3 of f of x all over the limit as x approaches 3 of g of x. Now, the limit laws that we have up here are actually not going to apply because look at number 4 right here. If our denominator is 0, this does not work. So this limit is a DNE. So this limit, let me write this better. I'll just say about this limit does not exist. I want you to get in the habit of writing why a limit does not exist in this part of the course. It does not exist. Why? Because we cannot divide by 0. Okay. Next one here is we have the limit as x approaches 3 of x squared times f of x. This is the same thing as the limit as x approaches 3 of x squared times the limit as x approaches 3 of f of x. Okay. Now for this limit right here, if you know that x squared is just a parabola, there's nothing that's not continuous about it. So if we look at the limit as we approach 3, that's the same thing as f of 3. Sorry, I'm just plugging in a 3 into the function. So this is just 3 squared times 2, so we get an answer of 18. Okay, so we can plug directly into a limit. Totally allowed, totally legal. Okay, let's come on down here. So we're going to start to find limits algebraically. So if you can find f of a, find it if it exists. If it does not, so let's say that you get something in the form of a 0 over 0, then you need to use the second star right here. So first off, we never, put this in red, never in your entire career of mathematics, never write this statement. Something equals 0 over 0. Never, ever, ever, ever write that. That is not a thing. Okay? Never write that. Ever. Seriously. Don't write it. Don't ever write equals 0 over 0. That's not a thing. So, but if we're ever in the form of 0 over 0, see the difference? In the form of 0 over 0, we want to use these bad boys. So this is in the form. Okay, then we factor if we can and reduce if we can. For some reason, if f of a results in a 0 in the denominator, then we're just going to find the right and the left limits, and then we'll just kind of go from there. For what we're doing for this part of the course, this is how we're going to do it. Calculus, you do it slightly differently, but let's go ahead and tackle this first problem right here. So if I were to plug in a -2 into a, the numerator would produce a 0. The denominator would produce a 0. So that would be of the form 0 over 0. Do not write equals 0 over 0, okay? So since that's in the form, of 0 over 0, I'm on this second star right here. So I'm going to factor and reduce if I can, multiply by the conjugate, or find a common denominator. So this one, I can factor this. So the top factors, oops, I don't know what has happened. There we go, top factors. So the top, that's a cubic one, so it's going to be x plus 2 on top, because your a value is x, your b value is 2 cubed, so it's 2. So it's going to be plus, this is a formula that you're supposed to memorize, all over x plus 2. So if you notice right here, we have a hole at negative 2. Because we're in the form of 0 over 0, we have a hole. So we can cancel that out. And this is equivalent to the limit as x approaches negative 2. Oh boy. Of just x squared minus 2x plus 4. And now we're not in the form of 0 over 0, so we can just plug in if we want. So we're going to get negative 2 squared minus 2 times negative 2 plus 4. And that gives us an answer of, I got 4 as an answer. Did you? Okay, cool. We match up. Great. Next one here. Again, if I plug in a 1 on the top, I'm going to get a 0 on the top. I'm going to get a 0 on the bottom. It is of the form 0 over 0. So let's go ahead and factor if we can. I'm going to do that right over here, because I can see that I ran out of space a little bit. This one does factor pretty nicely. I'm going to get x plus 1, x minus 3. And I'm going to get x plus 1, x minus 1. Okay, so the x plus 1s are going to cancel out. So this gives me limit as x approaches 1 of x minus 3 over x minus 1. Now, if I were to plug in a 1, I would get a 0 in the denominator, but the negative 2 on top. So this does not exist. Let's come back up here for my instructions. If f of a, which just means we plug in the limit, results in a 0 in the denominator, we're going to find the right and the left. So I want to find the right and the left at 1. So the limit as x approaches 1 from the right equals something, and the limit as x approaches 1 from the left. So what we should know from this course is that we have just a 0 on the bottom. That's going to give us a vertical asymptote. So we have a vertical asymptote right there. Okay, so I'm going to make a number line. Okay, and I'm going to kind of sort of, not really sketch this, but give you an idea of the sketches, and we're in positive and negative. I have a 0 at 3, and so that's a root. And then at 1, I'll put an open circle, I have the asymptote. Okay, so what's the end behavior? I think it's going to help us out a lot for this. At the end behavior, we're an odd function. So, well, even function, actually, because we have a power 1 on top, power 1 on the bottom. So we're even function. So we're doing some sign analysis here. We're going to go plus, and then if you plug in a number between 1 and 3, you're going to get negatives, and then you're going to get positives. Okay, so if I'm looking at 1 to the right, if you look at my number line, 1 to the right, those are negative values. Since this is a vertical asymptote, we're going to get negative infinity. Okay, and then from 1 to the left, I have positive values. That's a positive infinity. So I just found these infinite values because I know it's a vertical asymptote, and because I did my number chart or my sign analysis of when I'm positive and negative. So at 1, I know I have vertical asymptote. Just got to figure out what I got right there. Okay. For C, I'll do this in purple. For C, if I plug in a 2, what happens here? Well, this is going to be another is DNE. This does not exist because I get negative 2 over 0. So what I'm going to look at is I'm going to look at the limit as x approaches 2 from the right of this negative 2 over x minus 2 squared. And I'm going to look at the left-hand side. Okay, so like my number chart. Now, I only have vertical asymptote here at 2. Okay, and we're even, so it has the same end behavior. So if you plug in any value, you can just tell. If you like plug in a 3 or anything, you're going to get negative values over here. Plug in any value that's less than 2, like a 0, you're going to get negative values over here. So you get negative values everywhere. So as you approach 2 from the right, we do approach negative infinity. And as we approach 2 to the left, we also get negative infinity. Okay, so yeah. Letter D. Let's go a different color here. Let's try to make your eyes crazy by looking at all the different colors. Okay, on this one right here, if I plug in a 0, I'm going to get 0 on top, 0 on the bottom. I'm in the form 0 over 0. Let's come back up here. I can't factor this. Well, you can't factor this. So we're going to do the next step here is multiply by the conjugate. So I'm going to multiply by the conjugate here of the square roots, and that's going to produce us a nice little outlet here. So we're going to get x plus 3. Conjugate means you change the sign in between, not underneath the radical, in between. Okay, and when you do that, you kind of limit your limit your simplification. We're going to leave the bottom as is. Oh no. My writing is taking a turn. There we go. Okay, so that's the bottom. I didn't do anything. I just rewrote it with the x in front. But the top here kind of nicely, because it's the conjugate, the square roots are going to cancel out. I'm going to get x plus 3 minus 3. Oh no. My computer has been behaving. I have found out that it's actually not my computer. It's Cammy that's not behaving. Okay, so if you don't mind, I'm going to do a little bit of work here on the video so you can see this happen. So I don't have to rewrite anything because apparently I can't write things anymore. I'm going to get 3 minus 3. So do you agree that those cancel out? Just agree. Okay, so those cancel out. So I just have x on top. What happens to the x's? They're also going to cancel out. So this is going to cancel out with this. Okay, so what I'm left with is the limit. Oh boy. I got it. Hit and run this video here because this is not working out well. Oh boy. Limit as x approaches 0 of 1 all over. Holy cow. I'm going to try something in a second here, and I hope you don't mind. Sorry, my handwriting's so bad. I just need to do that. And when you plug into 0, you're going to get 1 over 2 root 3. No, I'm sorry. I'm going to just write this as best I can. 1 over 2. Oh, it's working now. Oh, maybe I don't need to try my thing. Okay, maybe it just worked itself. Okay, so that's the answer. You can rationalize that if you want, but I don't do that. Next one right here, can't factor. No conjugate can help us here because we have fractions. What we're going to do is we're going to make one big old fraction on top and then on bottom. So to do that, I'm going to multiply this fraction by 4 over 4 and this fraction by x minus 1 over x minus 1 to give me one big old fraction on top. So this is going to be the limit. So x approaches negative 3. And I'm doing this because when I plug in, oh, you know what? It's doing it again. I'm going to hit refresh, and hopefully all of my notes stay. Oh. And I lost power as I refreshed. Really got to pay them bills. All right. Hopefully I can write now, and hopefully everything's saved. If not, oh, looks like we all saved. Okay, cool. Hopefully this writes nicely now. So we're on pink. I'm just going to stay in the dark. All right, hopefully you write nicely now. Oh, you do. Wow, all year. I couldn't figure that out. So the numerator becomes 4 plus x minus 1 all over 4 times x minus 1. That's me combining just the numerator. I'm sick of this darkness. And let there be light. It didn't work. Help me. You know what? I'm stuck in the dark. I don't care. All over x plus 3. The top simplifies a little bit. I'm going to get x plus 3 on top because you're going to get 4 minus 1 all over 4 x minus 1. This is all over x plus 3. Dividing fractions is easy up high. Flip the second and multiply. This is the same thing as limit as x approaches -3. Top stays the same. Have you ever heard that before? Like you can respond. Well, dividing fractions is as easy as pi. You just flip the second and multiply. So when I do that, boom, cancel out there. So I'm left with limit x approaches -3 of 1 over 4 times x minus 1. When I plug in that -3, I'm going to get negative. I can't see my key anymore because it's dark. Turn on. I don't care. -1/16. Last problem, easiest problem, the whole thing. Do that in gray. All right. Can I plug in that 5 pi over 3? The answer is yes. There's no holes, nothing. This is equivalent to saying sine of 5 pi over 3. What is sine of 5 pi over 3? Anybody know that? It's in the fourth quadrant, so I know it's negative. Pi over 3 family is root 3 over 2. I would look at my notes and look to see if that's what I put, but I can't. All right, that's going to wrap up this video. That's it. Goodbye. Like, subscribe, whatever else I say.